Okay, so there are 6 gas laws altogether. There's Boyle's, Charles, and then combined, to combine those two. And help me out, what am I missing? Guy-Lussick's. It's pronounced Guy, by the way. Ideal I'm going to do last. And Dalton's law of partial pressure is the other one. Okay, so I'm going to do one example of each, but before I actually do example problems, I have like little maps, and it's on that, come on in, it's on that cheat sheet that you're going to get when you take the test. And I sent a copy to everyone, right? Yeah, I did that. So Boyle's law deals with pressure and volume. And according to Boyle's law, they do the opposite. So if pressure is going up, volume goes down. If pressure goes down, volume goes up. The book says inversely proportionate. It just means it does the opposite. Charles' law deals with temperature and volume. And according to Charles' law, they're directly proportional, or they do the same thing. So if temperature goes up, volume goes up. Temperature goes down, volume goes down. Then I use this little arrow system to set up my problems, because the bigger number always follows the second arrow in the problem. And I'll show you what I mean when we get to examples. Then combined gas law, you just have a Boyle's pressure, parenthesis, and a Charles temperature, parenthesis. So the same thing here, just we have to do both of them. Or vice versa. You understand that those arrows could go either way as long as they're going, like these have to go opposite ways all the time, these have to go the same way all the time. Guy-Lussick's law deals with pressure and temperature, no volume. And Guy-Lussick's law says they are directly proportional, or they do the same. So if one goes up, the other goes up. If one goes down, the other goes down. Dalton's law of partial pressure is the easiest one, I think, because it's just a bunch of pressures added together, partial pressures. It could go all the way to 50 or whatever. And that all equals the total pressure. So the way to make Dalton's law problems harder is if I were to, let's say I'll give you the first pressure and the second pressure, and then I'll give you the total pressure, but the third pressure is missing, or the fourth pressure is missing. And then you just add up the ones you know, subtract it from the total, and that tells you the missing one. The only way I could have 2 missing is if they were identical, and then you would just take that one final answer and divide it by 2. Does that make sense? All right, that's a pretty easy one. Ideal gas law, the way I was taught it is to remember pervert nert. I don't know, that just made sense to me and stuck. PV equals nRT. P is what? Pressure, V is volume, T is temperature. R is always the gas law constant. 0.0821, which anyone that lives, I think Holton Lake, their phone numbers all are 821 and then 5782 or whatever. So Holton Lake people usually have an easy time remembering that. But that goes for R. And R does have a label, but the label for it is all this other stuff combined so that everything cancels. You know, if you have something on top, something on bottom, they cancel out like I did last time. So it's really long and kind of confusing. But I can show you that later if you want to. And then N, we talked about N last time too. N equals moles. So notice that's the first formula, if you can call those formulas, that has N in it. So that's a big hint that you're using pervert nert in order to solve the problem, is if it has N. A big hint that it's a Boyle's law problem. What's missing? Temperature is missing. So either temperature is not included at all in the problem, or both temperatures that are given are the same temperature. So it's not changing. So it's not part of the problem. So then you do Boyle. Charles' law, what's missing? pressure is missing. So either both pressures are the same, or pressure's not in the problem at all. For combined gas law, there's nothing missing. Everything's there because you have to do a Boyle's, which is missing temperature, but then temperature is here for the Charles, but then pressure is missing. So there's nothing missing. There's 5 numbers that you'll have. Guy-Lussac's, a big clue is Guy-Lussac's law is volume is either constant, it'll say volume is constant, or it'll tell you it's in some kind of a metal container. It's in a copper sphere. It's in a lead square or whatever, cube. Because then the volume can't change. And then Dalton's law of partial pressure is just a whole bunch of pressures in the problem. Which, that one can, I guess, look tricky because I could give you pressure in a bunch of different labels or units. I could give one of the pressures in ATM, one of it in millimeters of mercury. I could give one of it in kilopascals or PSI. And you have to convert them all to ATMs and then do this. Add them all up, subtract from the total or whatever you need to do. So that one kind of looks hard, but it should be the easiest one. Converting, I guess, would be the hard part. Whenever you're doing any of these, pressure has to be in ATMs. And there's little conversions on that cheat sheet that you get to use to make them all ATM. Temperature has to be in Kelvin, which 273 Kelvin is the number that you have to use to get, to convert between Celsius. If you were given a Fahrenheit temperature, first you'd have to convert to Celsius and then do the 273 to get to Kelvin. Volume is in liters. So if you have milliliters, you just change that to liters. Something else here, unofficial, really. Wid-swiv. When in doubt, start with volume. Previous problems, we only had one problem or one number in the question, so that was obviously what we started with. In these problems, we're going to have many. In fact, combined gas law, you have 5 numbers in the problem. So if you're in doubt, don't know where to start with the volume and see what happens. That's just a little trick that I was taught. Okay, so that's gas laws in a nutshell, but I want to do at least one practice problem for each one of these, and then we'll go on to chapters 13, 14, and 15. Maybe. Okay, new color, I think.